Yeah. Next, real variable function. The function f from a to b is said to be real variable function if a is subset of R. Means all the elements of set A must be real numbers. Then the function is said to be real variable function. All the elements of set A are real numbers, then function is real variable function. Real valued function. The function f from a to b is said to be real valued function if b is subset of R. It is, for example, this is set A, set B. Set B is subset of real number, then the function is said to be real valued. If A is subset, variable. B is subset, valued. Suppose both A and B are subset of real number, then the function is said to be real function. Only A is belongs to R, variable. B is belongs to R, means B is subset of R, valued. Both are subset of R, then the function is real function. Next, difference, product and quotient of real function. Real function means both A and B should be subset of real number. Here f and g are two real functions. Here domain of function 1 and function 2 should be common, means we need to take common domain from f and g. Okay, na? So two functions are there, f and g, both are real functions. Okay, we have to take common domain from these two functions to do these operations, plus, minus, into, divide. Now let us see the properties. Two functions, when you are adding f plus g, two different functions with the same domain, that you can write it as f of x plus g of x. Both x must be belongs to same domain. Domain should be same from f function and g function. F minus g of x, two functions difference we are finding. X means it's a common domain from f and g function, that we can write it as f of x minus g of x. F into g of x means product of two function. Here x is common domain from f and g. This we can write it as f of x into g of x, where x belongs to d. D is a common domain from f function and g function. Now f divided by g of x means two functions we are dividing. This, how we can write f of x by g of x, where x is common domain from f and g function, and g of x should not be 0. Okay, na? All the domain, common domain you can take, other than when g of x is equal to 0. Why g of x should not be 0? Because if it is 0, the function's value cannot be defined. So to real function, when we are taking and adding, subtracting, multiplying, dividing, in that case we need to use the common domain from the f and g function. Okay na? Composite function. F is a function from a to b, g is function b to c. Composite function of f and g, two functions we are combining, is denoted by GOF. GOF, it is from a to c. Okay na? How to find the value of GOF of x? G of f of x. X belongs to set A. So if I say like this, you never understand. Let me show the example. Here f of x is 2x, g of x is x plus 1. I am taking some natural numbers. F function from a to b, g function from b to c. If I take 1, f of 1 is nothing but 2 into 1. 2 ones are 2. If I take 2, 2 twos are 4. If I take 3, 3 twos are 6. These are domain, these are range to the function f. Okay. Now g function, range of the function f, now I am using as domain of the g function. I repeat this. Domain of function f is 1, 2, 3, range is 2, 4, 6 to the f function. Now in g function, this range of f function, now it is domain for the g function. Now I am substituting g of x plus 2. 2 plus 1, 3. And 4. 4 plus 1, 5. 6. 6 plus 1, 7. Now this is one function, this is another function. Both are real functions. A also real number, b also real number, so f is real function. B is real number, c is also real number, g is also real function. Now how to combine these two functions, f and g? When you combine these two functions, that meaning you are connecting two different functions and make it as a one real function. F and g both you are combining. So simple way, one machine is there, something you input, some output will come from that machine. Again this will go to another machine. That machine also produce something and output comes 3. Means when two machines are there, first my input is 1, that machine output is 2, this output goes to another machine as input, that machine produce 3. So ultimately my initial input is 1, finally I am getting 3. So when you combine these two functions, my initial input is 1, my final output is 3. Means when I combine these two functions, that is denoted by GOF, G to F. This meaning my starting input is 1, output is 3. Means from the set A to C. This is GOF meaning. Two machines are there. First machine input, output is 2. This output again as an input for the second machine. Then ultimately output is 3. That means when you put 1 rupee coin, you are getting the number 3. Okay na? The number 1 you are feeding to your system, it converted to, again that enter to the another function, finally you are getting result 3. Okay na? So another example, if I want to tell you, f function, when you substitute, means when you enter the roll number, it shows your name, that is f function. G function, when you give the name, it shows the result. Okay, f function is when you give the input, your register number, it gives your name. G function, when you give your name, it shows the result. Two machines are there inside the box or your computer or wherever. I enter my roll number. Okay, it shows the name. Your name is 2. This name I given to another machine G. It shows the result 3. Okay na? So my initial input is register number. Final output is my result. Okay na? This is how the two different function, when we are combining, how to say that from G to F is a function from A to B, G is function B to C. When we combine these two functions, that is denoted by GAF. GAF matlab from A to C relation we are telling. Okay na? Let me give an example. Here, see, GAF of x from A to C. How to write this? G of f of x. Okay na? What is f of x function? Fx function is 2x. F of x plus 2x. What is g of x? This everything you consider as x now. What is g of x function is saying? X plus 1. X plus what is there? 2x plus 1. This is my GAF function, 2x plus 1. When you combine f and g, the composite function is 2x plus 1. GAF means from A to C. Now, let us check. Take the GAF condition, 2x plus 1. GAF means from A to C. A, what is the first element? 1. Substitute here to the GAF function. GAF of 1. X plus 1. 2 ones are 2 plus 1, 3. Means when you combine these two functions, that is called GAF. When you substitute 1, you are getting 3. Okay na? Similarly, GAF of 2. 2 2s are 4 plus 1, 5. For 2, ultimate result is 5. For 3, 3 2s are 6 plus 1, 7. Ultimate result is 7. This is how when we combine the two different real functions and how to name them. What does that mean? When you combine these two functions, that meaning you are relating from A to C. Okay, simple example I will give. For example, f is function from x to y. G is another function, y to z. H is another function, z to p. Suppose we are talking about g and h. G is one function, h is another function. We are combining this. When we combine f and g, we are writing GAF. When we combine g and h, we should write HOG, HOG. Okay. So g is from y to z, h is from z to p. This is one function, h is another function. G is y to z, h is z to p. When we combine these two, that is denoted by HOG, HOG. This is from y to p. Remember this. When we combine f and g, that meaning is what? The function f and g, when we combine, that is denoted by GOF, means from A to C. Similarly, g is one function, y to z, h is another function, z to p. When we combine these two, that is denoted by HOG. That means y to p relation we are telling. Okay. Next, here f is a function from A to B, g is B to C, h is C to D. Okay, I have taken some real function. Fx is 2x, g of x is x plus 2, h of x is x plus 3. F is A to B. I am taking 3 input, 1, 2, 3. I will substitute here. If I take 1, 1 2s are 2. If I take 2, 2 2s are 4. If I take 3, 3 2s are 6. These are the outputs. This g function related from B to C means f function output will be input of g. This input I am substituting to the g function. G of 2, 2 plus 2, 4. 4 if I substitute 4 plus 2, 6. 6 if you substitute 6 plus 2, 8. These are the output of g function. Now h function from C to D. From C to D, that is h function. Means output of g will be input of h. Now let's input these to the h function. When I substitute 4, 4 plus 3, 7. If I substitute 6, it will become 9. 8, 11. Now f is a function from A to B. When I combine these two functions, how to write? Already I explained. H of g. H of g means these two functions you are combining from B to D relation you are finding. That's what the meaning of H of g. F is a function from A to B. When you combine these two functions, that is denoted by H of g. When you combine these two means you are telling the relation from B to D. Look at this. A to B, B to D. A to B, B to D means directly we are going to say from A to D relation. How to say? By using these three functions. The relation from A to D. These two I combine. I made it one function. This is one more function. Now I am combining these two to say the relation from A to D. Very interesting. Have a patience to understand. See, this is one function, this is another function. A to B, B to D. These two functions when you combine these two functions, h of g of f. See, when I combine f and g, I say g of f. When you combine g and h, I will say h of g. F is one function. This h of g is another function. These two functions when you are combining, first you should take h of g of f. Okay, na? That means when you combine these two functions, that complete meaning is you are just telling the relation from A to D. Okay, na? Now how to expand this? How to find the functions? Here first f of x function we should take. What is f of x? That is 2x. So f of x plus 2x. Now g of this entire thing I should assume as x. G of x. What is g of x function? X plus 2. So now this entire thing I should assume as x. So x is 2x plus 2. Because g of function is x plus 2, x means this plus 2. Now this entire thing you assume as h. What is h function? That is x plus 3. So now this entire thing you assume as x, 2x plus 2 as x plus 3. 2x as it is, 2 plus 3, 5. This is my h of g of f. Means when I combine f function and h of g function, two functions, ultimately I am getting h of g of f function, that is 2x plus 5. This is from A to D. Whether it is satisfy the conditions or not, let us check. Here I have taken the function h of g of f. The function is nothing but 2x plus 5. Okay, now just normally how to find, let us do. First f of 1 I will take. F of 1 time what I am getting? 2. This 2 I am substituting to g function. I am getting 4. This 4 I am substituting to h function, I am getting 7. Similarly I have done. Whether this is correct or not, let us check. My function is 2x plus 5. Yes or no? When I combine the f function, when I combine this f function and with these two functions, I got h of g of f of x, that is 2x plus 5. This is from A to D. First element of A is 1. Substitute. If I substitute 1, 2 ones are 2. 2 plus 5, 7. So see, ultimate answer 7. When input is 1, output is 7. Now let me take 2. When I take 2, 2 2s are 4. 4 plus 5, 9. Look here. Input is 2, ultimate output is 9. Now let me take 3. 3 2s are 6. 6 plus 5, 11. So input is 3, output is 11. So these two one function, I combine them. This is another function. This combined function I consider as one function. Then I combine these two functions, I got this condition. And by using this condition, directly I can say for the input 1 what is final output, for input 2 what is final output, for input 3 what is final output. So this is how we can combine the different real functions one to another. Okay, now students, here you need to remember, when you combine f and g, that is denoted by g of f. When you combine these two, h of g. Okay, na? And remember, when you are combining these two functions, this function output, this function input should be same. When you are combining g and h, output of g should be input of h. Then only you can combine these two. Okay, na? Or else you cannot. Now let us go to the challenges and packages. Thank you, students.